Welcome to Narayan PU online classes. So in the previous episode, we completed objective questions exercise 11.2 up to question number 38. In this today's episode, we will discuss the remaining questions. Let us turn our materials, page number 24, volume 4 chemistry. Let us see question number 39 we have. The boiling point of an aqueous solution of a non-volatile solute is 100.15 degrees Celsius. What is the freezing point of an aqueous solution obtained by diluting the above solution with equal volume of water? The values of Kf and Kb for water are 0.512 and 1.86 Kelvin mole inverse. They are asking a freezing point of an aqueous solution. Clear? Here actually we want to use two formulas we have. Clear? See, the boiling point means we have the formula delta Tb is equal to Kv into M, and if you take the depression freezing point, delta Tf is equal to Kf into M. So these are the two formulas only. So you know delta Tb, you know what the formula we have? Tb minus Tb naught. Tb minus Tb naught. So generally water boils at water temperature, that is 100 degrees Celsius. At the given boiling point of the solution is given 100.15. So Tb how much now? This is 100.15 minus boiling point of the pure solvent, that is water 100 only. So how much you will get? Delta Tb you will get 0.15 degrees Celsius. So clear? What is the formula we have? Delta Tb is equal to Kb into M. Clear? Delta Tb you got 0.15. In the problem they given Kb and Kf for water is given. Clear? So what is the Kb value given? The Kb value given is 0.512. Now I am taking here 0.15 is equal to the Kb value we have 0.512 into small m. What is small m? Molality only. Now here m is equal to what you will get, man? 0.15 by 0.512 we got. 0.15 by 0.512. But here one more point also mentioned here. What is the freezing point of an aqueous solution obtained by diluting the above solution with the equal volume of water? So this solution is diluted with the equal volume of water. Then what happened here? The number of moles becomes what here? Half of the initial value. Suppose number of initial moles you are taking 1. After dilution, what are the new moles will be formed? That is 1 by 2 moles is formed. Okay. After dilution, new number of moles that is equal to 1 by 2 only. Now I want to multiply this 1 by 2 with molality. Molality M is equal to 1 by 2 into 0.15 by 0.512. Okay, here what you are finding? We are finding the molality of the solution of. Now, by using this molality, I want to find out the freezing point of the solution only. What is the formula we have? Delta Tf is equal to Kf into M. Clear? What is delta Tf? Delta Tf you can write here Tf naught minus Tf. That is equal to what is the Kf value given in your question? That is 1.86. 1.86 into molarity air forming. Okay, so generally water freezes at what temperature? 0 degrees Celsius only. Okay, I am writing here 0 minus TF not TF, that is equal to 1.86 into what is the molarity value we have? That is 1 by 2 into 0.15 by 0.512. 0.15 by 0.512. Okay, if you do this calculation part, okay, if you do this calculation part, nearly you will get nearly we will get here how much means 0.272 degrees Celsius water. This is what 0 minus TF, that means delta TF only. So 0 minus TF naught is equal to 0.272. You will get TF naught is equal to minus 0.272 degree Celsius. So clear? So they give an option directly in the option 3, that is minus 0.272 degree Celsius. So this is question number 39 we have. Question number 39. Let us see question number 40 we have. See question number 40, they ask me here, an ideal solution of a non-volatile solute B in a solvent A in a 2.2:5 molar ratio has a vapor pressure 250 mm. Another solution and the ratio 3:4, which is prepared. What is the vapor pressure of this solution? They ask now. Vapor pressure of the solution asking. Clear? Initially they given what? Non-volatile solute B and solvent A, molar ratio is given. Means what is the ratio of A and B? A and B ratio suppose they given B is to A is given. The molar ratio of B is to A is how much given, man? This is 2:5. That is mole ratio. Okay. Another solution prepared. Another solution is prepared in what ratio? Another solution, suppose you are taking B is to A again. That can be prepared in what, man? 3:4 ratio. Has a vapor pressure. They given one more point also. Vapor pressure they given how much means here 250 mm. Now what they ask here? Vapor pressure of the above solution is initially we have the number of moles ratio solute to solvent. Okay, solvent to solute is given. Solute to solvent is given 2:5 and B is to A is given 3:4. Clear? And the vapor pressure initially how much we have 250 mm. So generally how we get the ratio? We want to add a non-volatile solute. Okay. When a non-volatile solute is added to volatile solvent, what happens? Generally, you know the concept. When a non-volatile solute is added to volatile solvent, the vapor pressure of the solution is decreases. So the vapor pressure of the solution what decreases. Initially, what the vapor pressure is given? 250 is given. So what the answer will get? The answer will be less than 250 only. Let us see the options what we have. First option given 200, next 250, next 350, next what? 400 only. Clear? When a non-volatile solute, is added to volatile solvent, vapor pressure is what? Decreases. That is vapor pressure of the solution is what? Decreases. So the answer will be what? That is less than 250 mm of 250 mm only. So what is your answer here? That is 200 mm is the answer. Clear? So this is concept oriented method only. Okay. Another method also we have. How can you find out this 200 mm means we want to find out the mole fraction of the solute only. Mole fraction of the solute we have to find out. Then you can substitute in this formula. You will get 200 mm of Hg only. So how we are finding here? mole fraction of the, suppose I am taking solvent, mole fraction of the solvent in first case. This is solute, this is solvent only. Okay, then what you will get now? 5 by 5 plus 2 only. Yes. So 5 by 5 plus 2 means what now? 5 by 7. You will get here 0.71 only. 0.7. You know one formula, so P is equal to PA naught into XA1. P is equal to what? PA naught into XA. What the vapor pressure is given here? Vapor pressure is given what? 250. That is equal to PA naught into, what is the mole fraction you got here? 0.71. Now you will get PA naught is equal to 250 by 0.71 only. 250 by 0.71. Okay, then what you will get here? You will get 352.11 only. So this is PA naught value only. Okay, now we can substitute this value in another formula by taking the same formula with the second molar ratio. Clear? Now I want to write what the molar ratio of the second solution we have. That is what, man? 3:4 only. Now I am writing here mole fraction of the solvent. Mole fraction of the solvent, what you will get my here? 4 by 3 plus 4 means what my here? 4 by 7. 4 by 7 means what here? 0.5. 0.57 we got on. Now I am writing here P is equal to PA naught into XA. What is PA naught? What is this? 352.11 into this is how much, man? 0.57. You can multiply this one, how much you will get? 200. So this is a calculation method. This is a concept working method. You can follow the first method only. What is the answer for this question? Option 1. Now we can see question number 40 we have. In ideal solution, a non-volatile, two liquids having vapor pressure P1 and P1 naught and P2 naught in pure state is 2:1 ratio are mixed in the molar ratio of 1:2. The ratio of their moles in vapor phase means they ask here what? The mole ratio in vapor phase they ask what? Clear? What is given here? P1 naught by P2 naught ratio is given. That is a 2:1 means 2 by 1 only. Clear? And their mole ratio is what, man? N1 by N2 also given. That is a 1 by 2 only. That is given what, man? 1 by 2. From this we want to find out the mole fraction of the solute and the mole fraction of the solvent. Now I am writing here x1 is equal to 1 by 1 plus 2, that is equal to 1 by 3. Clear? Now from this we are writing x2, that is equal to 2 by 1 plus 2, that is equal to 2 by 3 only. Clear? This is x1, this is what, man? x2, and we have P1 naught and what? P2 naught only. Now the vapor phase in okay, what they ask, the ratio of the moles in vapor state. Now in vapor state, generally I am writing here y1 is equal to P1 naught into x1. In the same manner y2 is equal to P2 naught into x2. Now I am writing here y1 by y2 P1 naught into x1 by P2 naught into x2. What is P1 naught? P1 naught means 2 here. This is 2 into x1 how much? 1 by 3 by what is P2 naught? P2 naught value is 1. Okay, into this x2 value we have 2 by 3. Clear? So here 2 by 3 and what? 3 by 2. 3 cancel and 2 cancel. What is the ratio we get? 1:1 only. Means y1 is to y2. What is y1 and y2? Y1 and Y2 are what, man? Mole fractions are particles in what? Vapor state only. What is the ratio you got? 1:1. So the option is what, man? 1 only. This is question number 41 we have. 41 only. Now we can see question number 42 we have. 42 you can see when mercury chloride is added to an aqueous solution of potassium iodide, what are the changes we are observing? Okay, what are the changes? The boiling point does not change, freezing point is raised, the freezing point is lowered, and freezing point does not change as moment. Mercury iodide is added to potassium iodide. Mercury iodide formula we have HgI. It is added to potassium iodide Ki. That gives rise to K2 HgI. Is potassium mercury iodide you are calling. What is the name of this compound? This is a Nessler's reagent. Clear? Now here let us see the number of ions before the reaction and after the reaction. This is Hg plus and I minus. This is K plus and what? I minus. Here we have 2 ions and here we have 2 ions. What is the total number of ions? Means the total number of ions we have 4 ions are there. Clear? Now in the equation, how many ions we have? This is 2K plus and HgI4 minus. Here 2K plus and HgI4 minus you will get. Then here 2 and this is one total how much? 3 only. What is the total number of ions we have? 3 ions are there. After the reaction. Before the reaction 4 we have. After the reaction what? 3 we have. Generally it is considered as a strong electrolyte. Then what happened here? Number of ions is decreased. Means what now? 1.5 factor is what? Decreases only. So generally you know one concept. Generally if I increases, okay, it is particularly related to what changes are observing. If I increases, boiling point is what man? Increases. Vapor pressure is decreases, osmotic pressure increases, freezing point decreases. Freezing point decreases. Clear? Now here high increases, boiling point increases. But you see the first option, the boiling point does not change. That is wrong one. Next, second option you can see the freezing point is raised. Okay, generally you can say I increases, freezing point increases. But what about I here? Increase or decrease? Number of I decrease or not? So number of I decreases what? I value decreases. So I value decreases. What is the freezing point? Freezing point is what? Increases. Okay. So in this question, what you can say here? Number of ions. Okay, na? Decreases. Number of ions is what? Na? Decreases. Number of ions decreases what here? I decrease what man? Freezing point is what? Increases. Clear? Now we can see the second option. The freezing point is raised. The freezing point of the solution is what man? Raised on. So that is question number 42. Next you can see question number 43 we have. Clear? The molecular weight of a benzoic acid in benzene as determined by depression in freezing point method corresponds to the molecular weight of benzoic acid. Benzoic acid is a solute that is taken in what solvent? Benzene solvent. By the depression in freezing point metal corresponds to which one? So generally benzoic acid form a dimer in what man? Benzoic acid form a dimer in a benzene solvent only. Clear? Benzoic acid. Benzoic acid forms dimer in benzene. What is the formula of benzoic acid, man? Benzoic acid formula we have C6H5COOH. Okay, this is C6H5C. Okay, double bond O. This is one of the benzoic acid, and you can take here another molecule of the benzoic acid also. Okay. So here two molecules of the benzoic acid, they will correspond to form what one means here hydrogen bonding. So this is what here this is the formation of dimer in benzene sulfate. So what is the answer for this one? That is option 2, dimerization of benzoic acid. Dimerization of benzoic acid. Okay. Now you can see question number 44 we have. Question number 44. Let us see this question number 44. The vapor pressure of a solvent decreases by 10 mm of Hg when a non-volatile solute was added to volatile solvent. The mole fraction of the solute in the solution is 0.2. What should be the mole fraction of the solvent if decreases in vapor pressure is to be 20 mm of Hg. Here, so the vapor pressure of the solvent is decreases. Vapor pressure of the solvent is decreases means it is a P0 minus P0. How much is given? 10 is given of Hg. When a non-volatile solute added to volatile solvent, the mole fraction of the solute is how much? 0.2 ohm. Here, you know one formula, P0 minus P by P0 is equal to mole fraction of the solute. Mole fraction of the solute. They already given the decrease in the vapor pressure, that is how much given by 10 by P0 is equal to what is the mole fraction of the solute in the solution is given, that is 0.2 is given on it. Now here what will you get? P0, can you find P0 here? So P0 is equal to what will you get? 10 by 0.2. 10 by 0.2. Can we get here 50? So 10 by 0.2 which will multiply divided into 10. This 100, this is 2, 2 times 50 times cancel. So P0 value how much here? 50 ohm. Now the question you can see again. What should be the mole fraction of the solvent if the decrease in the vapor pressure is to be what? 20 mm of Hg. Means again here P0 minus P by P0 is equal to, they ask here what is the mole fraction of the solvent. They ask what mole fraction of the solvent. So here what should be the mole fraction of the solvent if the decrease in the vapor pressure how much? 20 mm of Hg. So decrease means what here? P0 minus P by P0. Already P0 we are finding how much here? 50. That is equal to mole fraction of solute getting. This is mole fraction of the solute. So what do we get here? 0.4 is equal to mole fraction of the solute. Now mole fraction of the solvent is equal to 1 minus 0.4, that is equal to 0.6 is the answer of it. Clear? You can see the option, direct option we have, that is option 3, that is 0.6 ohm. Now you can see question number 45 we have. The substance A when dissolved in solvent B shows the molecular mass corresponding to A3. The 1/2 factor will be, we want to find out the 1/2 factor for this question. So what are the compound is given? A is converted into A3 only. Okay, this is a question number 45 we have. A is converted into A3. Means suppose you can balance what you are taking here. 3A gives rise to A3. So A gives rise to A3 means this is what? Association. What it is? Association. They are asking what are factor I value. Okay. Number of moles of A after association by number of moles of A before dissociation. Number of moles of A after association by number of moles of A before association. So you can take here number of moles of A after association. How much? 1 only. By before association, how much we have? 3. That is what? 1 by 3. Simply they give n and a. What do we get? 1 by n only. So what is the n value we have? 3. Directly you can get 1 by 3 only. So this is question number 45 we have. So this is completion of exercise level 2 questions.